Okay, so we're going to look here at the action potential, depolarization, and repolarization, and what is exactly happening to the membrane. So this is at what we call resting potential membrane, all right? So at resting potential, we're going to have that membrane that's like the salty banana. We have got a more positive charge on the outside because there are more sodium ions on the outside. Sodium ions here are represented in red, and so you can see it's kind of hard to see the colors there, but you've got more red sodiums on the outside. You can see that in these numbers here, 145 millimoles of sodium out here and 10 millimoles of sodium in here. Potassium is just the opposite. It's going to be the green diamonds here. We have 4 millimoles outside and 140 millimoles inside. And so we have a potential difference. This is a polarized membrane, positive on the outside and negative on the inside. And so we're going to send an action potential, and you're going to see these charges here, positive on the outside, negative on the inside, are going to depolarize. They're going to come closer together where they're both almost negative for a while. And then we're going to have what we call repolarization, and that's where they become positive on the outside and negative on the inside again. Okay, so I'm going to try to pause this as we go through and explain. So we're going to start by stimulating the neuron. Before I do that, we've got our sodium-gated channels here and potassium-gated channels, and those only open due to that electrical action potential. That triggers them when you hit our threshold amount. When you get to negative 70 millivolts, they will open up and allow ions to flow through. The potassium ions, the sodium ion channels will open first. Sodium ions will flow through, and then the potassium ion channels will be triggered, and those will flow out. So sodium in, potassium out. The leak channels are kind of open all the time. Okay, so let's stimulate our neuron with an action potential. Now watch that membrane. Now looky there, it's changing, okay? It went from negative, look there, both times we lost our potential difference, okay? So we had positive, and now we're changing, it's becoming more negative. We're allowing more sodium ions to flow through, okay? So they're changing. Sodium ions are flowing through. Potassium ions now, if you'll notice, are beginning to flow out. They've actually already flown out, so let's back this up. So this left side where the line is increasing, that is a depolarization. Sodium ions are flowing in. Okay. Then when the sodium ions trigger the potassium gates to open, when those open, you will see it's going to repolarize. Okay. And so we're going to open up those channels. Watch, the actual channels will open up. See how they become wide and they allow the sodium ions in. We are depolarizing. Okay. So about right here, there's no more opposite charges. It's depolarized. Okay. Then when we get enough of those in and the potassium begins to flow out, those charges come back. We repolarize. Look, it's more negative on the outside for a moment, more positive on the inside, okay? And so we're repolarizing it. We're going to have enough of that change. Okay, now we're positive on the outside and negative on the inside again. And I want you to notice down here, we're actually below this original line. So we call that the overshoot or hyperpolarization. Okay. All right, and then it is going to eventually be restored back up slowly by the sodium-potassium pump to the resting membrane status. You can see now here that line is going up, so that we're back at resting membrane potential. So that is our action potential. Remember, sodium ions going in. This portion here is depolarization. You're going to reach the peak and you're going to have those potassium ion channels open up, and then you are going to repolarize the membrane and come back to resting potential.